Section 5.3 is titled Solving Quadratic Equations by Graphing and Factoring. We're going to begin this section, and actually the majority of these notes we're going to review factoring, which is a skill that you have learned in Algebra 1 and quite possibly have done in geometry as well, but we haven't yet done it this year. And then we'll use that factoring to solve quadratic equations as well as we'll be solving them through graphing also. Before we get into factoring problems, I thought we'd review a related problem, which is multiplication of two binomials. And you might recall from your Algebra 1 days the acronym FOIL, which stands for first, outside, inside, last. You do it like this. The first in each binomial, x times x is x squared. The outside of the binomials, x times 6 is 6x. The inside, negative 4 times x is negative 4x. And the last in each, negative 4 times 6 is negative 24. We combine our like terms, which are these x's, and we end with x squared plus 2x minus 24. Okay. If we do it on this problem as well, the first to the first is x squared. Outside is negative 3x. Inside is positive 3x. And then the last are negative 9. The like terms here add to 0, so this one's just x squared minus 9. Now, what we are going to be doing in this particular section going forward and using to solve these quadratic equations is we are going to start with problems that look like this. And we're going to have to go backwards to that. Okay? And so understanding how to multiply and how to multiply well will aid in your undoing the multiplication. So when you start here and go back, you'll be better at it if you understand how to do this. Alright, so here we go. We're ready to do some review problems on factoring. So when we factor, we're going to factor this into two binomials. The first term of each of these binomials should multiply to give the first term of this trinomial, x squared. So we want x times x. Okay. Now, it's generally in these types, if it's just x squared, it's always going to lead with x and x. Okay. So the challenge here really is to try and figure out these two numbers. Now, these two numbers always follow this pattern. They are going to multiply to this number and add to that one. Okay? So I want two numbers that multiply to positive 3, and the same two numbers must add to positive 4. Okay? Well, that would be positive 3 and positive 1. 3 times 1 is 3. 3 plus 1 makes 4. And that's how you factor x squared plus 4x plus 3. Okay, another problem, same pattern. Into two binomials we go. X times x gets x squared. I want two numbers that multiply to 18 and add to 11. Okay, so 18 is 1 times 18. It's 2 times 9. It's 3 times 6. The pair of numbers that add to 11 are 2 and 9. X plus 2, x plus 9. Next one, begin with x times x. I need to multiply to negative 10. So that would be negative 1 and 10, or 1 and negative 10. It could be negative 2 and 5, or 2 and negative 5. Now I need the pair that add to negative 3. I'm going to add to negative 3. I want the 2 and the 5 combination with the bigger number 5 being negative. So I want positive 2 minus 5. Last one. X times x makes x squared. I want numbers that multiply to this one and add. That should be a 1, like a minus 1. So multiplying to negative 42, let's see, I could use 6 and 7 multiply to 42. If I want them to have a difference of negative 1, I would want the bigger number negative. Positive 6, negative 7. Next I want to do a couple of problems where we have a number other than 1 in front of the x squared. So you see there's a 2x squared here, there's a 3x squared on this one. I begin the same way as before, except instead of x times x, to get 2x squared, I need 2x times x. Okay? And I'm still going to multiply to 10. Okay, well, I have limited options there. It's 1 and 10, or it's 2 and 5. Okay? Now, I still need to add to 13. However, 1 plus 10 is 11 and 2 plus 5 is 7. Neither of those add to 13. But we have to consider the 2 that's sitting in front of the x right here. Think your FOIL product. Whatever number I set in this spot right here is going to be multiplied by 2. And that accounts into the addition to get to 13. Okay. Now, it just so happens that this particular problem has a typo in it. And I forgot that there was a typo in this problem. I think what we're going to do is change this number right here to a 9. If we change that to a 9, things are going to work out pretty good. Alright, so what number should we place here such that 2 times that number plus the other one is going to give us the 9? Well, I'm going to want to put the 2 from the 2, 5 combination. Okay, so let's check. 2 times 2 makes 4x. 5 times x makes 5x. These add to 9x. Okay, sorry about the typo, but that's it. Okay, the next one has a 3 in front of the x squared. So we're going to start with 3x times x. Okay, I still want to multiply to negative 4. I want to add to negative 11. So the ways I can multiply to negative 4 are negative 1 and 4, or negative 4 and 1, or negative 2 and 2. Okay, that's it. Those are my ways. Now, whatever number I place on the outside opposite this 3 is going to multiply by the 3. That's going to help create this addition to negative 11. So it's somewhat some guess and check, some trial and error. Sometimes it just pop right out at you. I'm going to put the negative 4 here of this pair, which leaves me positive 1 there. If I do that, the outside gives me negative 12x. The inside gives me positive 1x, which adds to negative 11x, which is what I want. Next, I want to look at some two-term factoring problems. All of these problems are examples of what we call difference of squares. Difference is subtraction, squares meaning perfect squares. They all factor into two binomials. It'll be x times x to make x squared. And what I want is the square root of this number. The square root of 9 is 3. So 3 and 3, one will be plus, one will be minus. It's similar to the first product, or the first slide we did that had a product problem on it that was like this. Okay, this next one, x squared minus 25 will be x times x. Square root of 25 is 5. 1 plus 1 minus gets the job done. Next one. Here, because the number in front of the x squared, I'm going to square root it 2. So I get 2x, 2x. Square root of 49 is 7. 1 gets plus, 1 gets minus, and it's that easy. Okay, the last one, 9x squared minus 1. We square root the 9, giving us 3x and 3x. We square root the 1, which is 1 and 1. 1's plus, 1's minus, and that's done. Okay, finally I want to do some example problems where you have to look for a greatest common factor first. Is there a common factor amongst the terms of the problem? And so the first one, 3x squared minus 12, is there a number that divides 3 and 12? And the answer is yes, and that number is 3. So dividing each of these by 3 leaves x squared minus 4. Now we keep the 3, and can we factor x squared minus 4? Well, it looks just like the last slide of problems we did. X times x makes x squared. Square root of 4 is 2. 1's plus, 1's minus, and that's it. And in this last problem, again, is there any number that divides all the terms? And the answer is yes, it's 2. So divide them all by 2, we get x squared plus 2x plus 1. Keep that 2 in front there. X times x makes x squared. I want two numbers that multiply to 1 and add to 2. That's not hard. It's going to be 1 and 1. 1 times 1 is 1. 1 plus 1 is 2. This is done like this, or you could even write it x plus 1 quantity squared, since there are two x plus 1s. Either of these would be acceptable and just fine. Okay, the next two slides contain 8 problems that you can try on your own. So this would be a great chance to get into the factoring. I would pause this, take a few minutes, try these 8 problems, and then replay or press play when you're done and ready to check through the answers. First one. Multiply to 30, add to 11, so x plus 6, x plus 5. Next one, we want to multiply to negative 48, add to 2. It's going to be positive 8 minus 6. Next one, we can take a 4 out. That leaves 4, x plus 2, x minus 2. Next one, I want to multiply to 54, add to negative 3. That's going to be negative 9, positive 6.